In this video, we are going to solve a quadratic equation using two different methods. The reason why we're going to do two different methods is to verify that we have the correct solution. If you do it twice and you get the same answer, you can be pretty confident that you have the correct solution. So, the first thing I want to do here is I want to use the quadratic formula. In order to use the quadratic formula, I need to collect all my terms on one side of the equation and have 0 on the other side. So in order to do that, I need to add 7 to both sides of this equation. So that's going to give me my 3y squared plus 12y plus 7 equals 0. So now that I have it in standard form on the left side, I'm able to determine my values of a, b, and c. A is 3, b is 12, and c is 7. Okay. Before I go ahead and start plugging the numbers into the quadratic formula, it's always a good idea to write the formula out so we don't forget anything. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what I do next is I create a skeleton. So everywhere that I see a variable, I put an open set of parentheses. That way, I don't miss anything and I don't make any mistakes. This is really crucial when your values of a, b, and c are negative because, for instance, when you're squaring b, if b is a negative number, you want to make sure that that negative sign goes in your parentheses so you know that the base is a negative number. So that way you get a positive answer when you square it. Again, we've talked about making sure you put parentheses around negative numbers if you're going to be squaring them. Same thing for the negative b. If your b is already a negative number, by making the skeleton, you'll see that you have a negative on the outside and a negative on the inside. So then when you take the opposite of b, you get a positive number. Like I said, all my values of a, b, and c here are positive, but it's good to get in the habit of making that skeleton anyways. Okay, so I plugged in my values of a, b, and c. So now I'm ready to start simplifying. So I'm going to get x equals negative 12 plus or minus the square root of 144 minus 84 all over 6. So that's negative 12 plus or minus the square root of 60 all over 6. And now, don't be tempted to do any simplifying just yet. You can't divide out a common factor of 6 because that 60 is underneath the radical sign. We still need to simplify that. So I am going to rewrite 60 as 4 times 15. And the reason why I chose to factor it as 4 times 15 is because 4 is a perfect square. And I will be able to simplify. So this gives me x equals negative 12 plus or minus 2. So the 2 comes from that square root of 4. Plus or minus 2 square root 15 all over 6. Now I can do even more simplifying. The 12, the 2, and the 6 all share a factor of 2. So I can divide all of those by 2. So the negative 12 becomes negative 6, 2 becomes 1, and 6 becomes a 3. All right. So over here, my final answer is going to be x equals negative 6 plus or minus 1 square root 15, which we can just say is the square root of 15, all over 3. So my solution set contains two real irrational solutions. Now, really quick, let me just point out back over here, when the radicand was 15, don't try to divide the 15 by anything because the 15 is under the square root sign. The only numbers you can divide out common factors are the negative 12 and the 2, which was the number that was being multiplied by the radical sign, and the 6 in the denominator. Okay, so over here we have two real irrational solutions. And the reason why I know they're irrational is because I have that square root of 15. And 15 is not a perfect square. So the square root of 15 is going to be an irrational number. So if I were to graph this equation, that means I would have two x-intercepts, but they would be crossing at irrational numbers on the x-axis. So my zeros, I would have two zeros, but they would be irrational numbers. All right, so now I have that answer. I want to solve this equation in one more way, just to verify, in fact, that I do have the correct answer. Now, the fact that they were irrational numbers, that I got irrational solutions on the other side, means that this is not factorable. If an equation is factorable, if you can factor one side of an equation to solve it, you would have gotten rational solutions. So the fact that I got irrational solutions tells me that I can't solve this equation by factoring. So what I'm going to do next is completing the square. But I can't complete the square unless my leading coefficient is 1. So what I have to do is I have to go through and divide everything in this equation by 3 so I can have a leading coefficient of 1. So now I have y squared plus 4y equals negative 7/3. So to figure out what number I need to complete the square, first I'm going to set up another kind of skeleton. So notice how I draw an empty square on both sides of my equation to remind myself that whatever constant I add to the left side, I also have to add it to the right. And I draw an empty square because I am completing the square. I'm trying to figure out what that missing number is that needs to go in the square. So in this case, my b value is 4. That is my b value. So to figure out what my missing number is, I need to do b over 2 squared, which is 4 over 2 squared, which is 2 squared, which is 4. So what that means is that 4 is the number that I need to add to both sides to complete the square. All right, so now I have a perfect square trinomial right here, and this factors to y plus 2 quantity squared. And on the right side, I have negative 7/3 plus 4. And I'm going to rewrite the 4 as 12/3 because I need to be able to add those together, so I need a common denominator. All right, now, real quick, let's make sure we understand how to get that number in the binomial squared. When you are doing your b over 2 divided by 2, right here, this step right here, when you simplify what's inside the parentheses, so I got 4 over 2, the number you get before you square it, whatever is inside your parentheses right here, in this case it was a 2, that is the same number that is going to go right there. So when you do your b over 2, before you square it, that number is going to be what's going to complete the square for you, or what number is going to complete the binomial, so you get a binomial squared. Okay, so that's how you know what number you put right there. Okay, so let's go back and finish solving this. So I have y plus 2 squared equals 5/3. And now I'm ready to use the square root property. So I get y plus 2 equals plus or minus square root of 5/3. Now, we want to rationalize the denominator here. We don't want to leave the square root of 3 in the denominator. So I have y plus 2 equals plus or minus square root 5 over square root 3, using my quotient rule for radicals. So to rationalize this denominator, I'm going to multiply both sides. It's a multiplication sign right there. I'm going to multiply, I'm sorry, not multiply both sides. I'm going to multiply the top and the bottom of this fraction by the square root of 3. So that is going to give me y plus 2 equals plus or minus square root 15 over 3. And now what I have to do is I have to subtract 2 from both sides. So this is going to give me y plus 2 minus 2 equals plus or minus square root 15 over 3 minus 2. And let's go ahead and let's finish it up over here. So I'm going to have y equals, now I'm going to put that negative 2 first. So I have negative 2 plus or minus square root of 15 over 3. So in order to combine these, my negative 2, I could think of that as negative 2 over 1. It needs to have a common denominator of 3. So that's going to become negative 6 over 3 plus or minus square root of 15 over 3, which I can combine as negative 6 plus or minus square root of 15 all over 3. So you can see I get the same two irrational solutions that I got on the other side, excuse me, that I got on the other page when I did the quadratic formula. So I can be confident that my answers are correct. Now, some of you might say, well, if I want to know if my answer is correct, why don't I just plug it back in? Well, that's fine when your answer is an integer or a whole number. But when you have an irrational solution, for instance, negative 6 plus or minus square root 15 over 3, you're going to have to plug all of that back in for the variable. That can kind of get messy. So by doing it in two different methods, you can verify that you get the same answer and that your answers are correct.